Welcome to TNL Physics. My name's Sarah, and today I am going to go through wave properties with you. The definition of a wave is it is a phenomena that transfers energy without transferring mass. You see, as I'm talking to you now, the sound waves are moving through the air. If we look at the particle before and after the sound wave has been, they would be in the same place. However, the energy has gone from one position to another. This is what is meant by transferring energy without transferring mass. If you look before and after the wave has travelled, the particles seemingly haven't moved. In particle physics, mass is when energy is transferred, mass is transferred. Think about it. When you heat up a cup of tea or heat up some water, the particles start moving around a little bit more. Mass is being transferred as energy is being moved around the system. So that is the key definition of a wave, that it transfers energy without transferring mass. There are two types of wave that you have to be made aware of, and there are some nuances to how we define those two waves. The first wave I'm going to talk about is transverse waves. This here is a transverse wave. It is the traditional sort of wave shape, like a sine wave you would see in mathematics. Now, the important part of a transverse wave is this, that the energy is transferred perpendicular to the direction of travel. And by that I mean, here is my direction of travel, and as you can see, if this was a piece of string, my particle will be moving up and down. That is perpendicular to the direction of travel. So energy is transferred perpendicular to the direction of travel. And in an exam, they will expect to see the word perpendicular or at right angles. Transverse waves include EM waves, water waves, and by that I mean your waves that are in the water, ripples, etc. And lastly, S waves, which is to do with geophysics and earthquakes. This one here is a longitudinal wave, and this is the second type of wave you need to know about. Longitudinal waves, energy is transferred in the direction of travel. And you can see that here, these particles are moving left and right. They are moving closer together or further apart, but this is in the direction of the travel. That is a key defining feature of a longitudinal wave, that these ideas of they will move together and further apart in the direction of travel. These regions where they are moving closer together are called compressions. These regions where they are moving apart are called rarefactions. And those are key defining terms that you need to be aware of, that these compressions and these rarefactions. A longitudinal wave include sound waves, as the particles are moving this way to transfer sound, and P waves. P waves, again, are another geophysics phenomena, and they come with S waves. Now, longitudinal and transverse waves both obey that rule of a wave. A wave is something that transfers energy without transferring mass. If we looked at the particles before and after the wave had passed, they'd be in the same position. However, there are some key differences in their functionality. A transverse only transfers energy perpendicular to the direction of travel, and longitudinal in the direction of travel. This means one very special thing between them. Transverse waves can work in a vacuum. Longitudinal waves cannot. That is the basic of wave properties, transverse waves and longitudinal.